let's look at our course structure and goals. So to begin with, an analytic is an inference from data that you use to make a decision or a prediction, often called actionable information. Typically, this is done with some kind of an algorithm. Diagnostic testing, positive for this type of cancer, is a prediction, and that prediction is an analytic. Analytic often uses information from multiple scales to get an optimal decision or valid prediction. A predictive model is an assignment of a probability to every possible outcome of a process. And notice, this is an algorithm. And a predictive model is what a machine learns in machine learning. The model is a probability distribution, and the prediction of the model is often an optimal distribution. Now, this is a subset of artificial intelligence. Analytics and predictive modeling is often called machine learning in computer science or predictive analytics in commercial contexts. APM, this abbreviation we'll use, is a fundamental component of data science. Data science is the application of convex optimization and numerical linear algebra to big data. And much of data science is via predictive modeling, which is mostly based on differential calculus. So notice linear algebra and calculus. These are prerequisites to this course. Now, there's a lot of artificial intelligence that is not solely based on calculus and linear algebra. In this course, we're going to focus only on that part of artificial intelligence and data science that is based on calculus and linear algebra without additional higher level mathematics. So there's a lot of it that we can do with that. And we'll briefly review these prerequisites as we encounter them. So the course goals to explore how predictive models transform uncertainty in big data into knowledge. Notice uncertainty and knowledge are both different types of information. Uncertainty information we don't know, and knowledge information that we do know. To introduce many of the algorithms in the data sciences used for predictive modeling. To develop the communication skills that are expected of professional data scientists, a very important goal. Let's look at the structure of the course. There will be 12 modules. You'll watch 3 to 5 videos. Each are approximately 15 minutes each. Attend course meetings for additional information, examples, discussion, review, questions answered. This interactivity is quite important. The course is built on calculus and linear algebra exclusively, but my experience is that doing that requires a lot of interaction between the instructor and the students. We'll have associated what we call Jupyter notebooks. There'll be optional readings and exercises as necessary, but these are review as needed. So if it's marked optional, it's not required. It's only there if you need more than what's already there. And there'll be some additional support materials on the course website. The assessment in the course, there'll be 10 weekly assignments. These are online quizzes, Jupyter notebooks. Most are short. Some can be more time consuming. Some will be conceptual, some will be computational, especially later. You're required to get an 80% or higher on each of the 10 weekly assignments. You can get no higher than 80% after they're due, but if you have at the time due a score lower than 80%, you have to keep working on them until you have at least an 80%. You'll have 1 week to complete the midterm exam. The last week will be review, and the final exam will already be distributed, and you'll be working on it. So the final exam will have a project-like format. The final exam in this course is very important. It's what you're going to use to say that you're a data scientist. It's going to help you with your resume or things you can discuss in a job interview or skills that you can say you have. The course has been carefully designed so that you need no background except calculus and linear algebra. But at the end, this course will equip you for employment or research in the data science field. So this will be my 11th time teaching the course. And in the previous 10, every student who desired to move forward in the field did so after this course. Again, the final exam was very important to this uh, completion. So the structure of the course, we'll start out with complexity and information. What is data science? Then modeling complexity, nearest neighbor methods, metrics, information, decision trees, and ensemble methods. And having completed these 7 uh, modules, we'll have our midterm. The second part will be algorithms as models. We'll start out with kernel methods, neural networks, deep learning, generative models, including transformers, and then softmax and what I call supermodels. And the final exam will be due by the end of the semester. So you'll have ample time to work on the final exam. The last 2 times I've taught the course, there were a minimum of 2 weeks. I think 2.5 weeks for one class and exactly 2 weeks for the other in the past 2 times I've taught it. So you'll have plenty of time to work on the final, and the final will be very important in this course. My expectations and your background, I assume you've completed a calculus sequence, assume you've encountered matrix algebra, a willingness to develop essential coding skills, especially in the past year or so. There's no need for you to be some kind of a superstar programmer. Uh, we can develop your programming skills in the course itself, and you'll see examples of how we're going to do that even in the first module. At the end, you'll be capable of participating in data sciences as you can call yourself a data scientist. So what does it mean to be a data scientist? Well, you have to be able to use abstract mathematics both conceptually and concretely. Because you have to tell a machine what to do with a very large set of data. So if you have a terabyte of data, you can't think of that in terms of individual numbers. You have to think of it as an abstract structure. You have to assess the quality and utility of what the machine does. So if you can't uh, say how good the result is, then the quality of what you've produced is limited. You're going to have to use computers both as a tool for working with data and as a context for developing and implementing algorithms. So we're not going to make you into a code warrior again, but you will become someone who can use code for these purposes. Very, very important. Being a data scientist means you have highly developed communication skills. You're going to have to explain results and how you obtain them to multiple stakeholders who will have many questions. Some of these stakeholders will have very little technical background. Some of them will have more background than you have. And they expect not just an answer, but a story. A story which informs their decision making as well as provides a context for their questions. You're also going to need to have a profound understanding of calculus, linear algebra, basic statistics, and basic coding techniques. Now, this is the basics. We're not saying that you need to be advanced in any of these fields, but the basics need to be something you deeply understand. The reason is common sense can often fail to explain complex data. And if you ever catch yourself saying, well, it's common sense, then there are 2 things. Number one, they all have common sense. The clients have common sense. Why would your common sense be any better than anybody else's common sense? And secondly, by the time they've brought you the data and the problem, their common sense has already failed and yours is not going to do any better. And because these models are built using calculus and linear algebra. So where they have shortcomings, is probably going to have to be addressed by somebody who has a profound and deep understanding of the calculus and linear algebra used to build these. And so we'll start by reviewing this required math when we meet the first week. There'll be a list of activities for you to do for the first module, but our interaction time, a lot of it will be spent reviewing calculus and linear algebra, in particular matrix algebra.